Hello, folks. Welcome to Rational Science. We have a great day today. We're going to be talking about the neutron, allegedly uh, it's a neutral particle. We're going to find out if that's true today, whether that's has any merit to it. But let's begin with the extinction headlines. We always talk about extinction first. Is is humanity, are humans going to become extinct? Like ever first? That's the first question we have to answer. And then very soon? We'll find out, right? Okay, here's a headline that came out this week. Says scientists think they figured out when the sun will explode and kill us all. Oh my God, I hope it doesn't happen next week. I was planning on going out to the park. I hope it does so. I hope the sun takes its time and does it in a million years or so, at least. It says the sun's life cycle will end as soon as 5 billion years from now. So how is it going to kill us all? While the idea of the sun dying is scary, there's a chance humanity won't even be around to experience it. Oh, okay. I thought so. But he says the Earth's oceans will be vaporized by energy from the sun, etc., etc. Okay, and so, but then he says at the time, the sun's brightness will also have increased by around 10%. There are also other threats of climate change to take into account as well. Okay, so I guess he's saying that if none of that kills us, then the sun kills us. Okay? Says the future of the Earth is grim. Perhaps that's why so many people are so focused on space travel and getting us to other planets. So people think they're going to escape the Earth. So when the sun explodes, we won't have to be around here, right? We'll be in a nicer solar system, I guess. One that's just beginning, we just move over there. And not only would it allow humanity to continue surviving, but it would give us a new home to go to when the sun eventually dies. I think a lot of these people have a lot of fantasy on their heads. They've been watching too much Star Trek. They think we're going to go to another planet, and then they're talking about the sun exploding and killing us. I don't think we'll be around by then, for sure. Okay, but that's my 5 cents worth. I think human extinction is right around the corner. We're the last humans on Earth. And these people are talking about the sun exploding and killing us. Okay, in a billion years. Okay, another similar headline. Ukraine, China, and climate change tagged as doomsday clock holds at 100 seconds to midnight, matching riskiest view ever. Yeah, there's this, for all those who are not aware of it, there's the Doomsday Clock. And it's been around since after World War II. And a lot of it had to do with the atomic bombs. Will we ever throw them again at each other? And so that's when they started with all this doomsday thing. Uh-oh, am I having trouble with YouTube? I hope I'm still on, fellas. Let me know because I got a message from YouTube here. Okay. Uh, Let me know if you can see and hear me. I just got a warning message that something's wrong. Let me know. I check everything to be okay. So let me know as soon as you can get your, so I get my bearings back. Okay. Okay. Well, I don't know. Okay. Thank you. Okay. Let me continue here. Said scientists, these atomic scientists. In fact, there's 11 Nobel laureates among them, and they claim these are the issues that are hot today that might uh, um, justify pushing that hand on the clock further and further to 12 o'clock. And that's one of them is the new variants of COVID-19. The other, the slow response of climate change. A lot of these scientists are worried, very much worried, that the politicians are not doing enough about climate change. And then there's all these possible wars like Ukraine, Taiwan, maybe coming up, maybe countries like Iran and North Korea, these mavericks out there that might throw nukes or build them or whatever. So, but despite this, the bulletin is optimistic about technological advances to mitigate existential risk, which is kind of strange because if it seems like a contradiction, because on the one hand they're saying the second hand is 100 seconds away from doomsday, and then on the other they say, oh, but we're optimistic. You would think we're optimistic. We're 15 minutes away, from doomsday. So you wonder about these scientists. Anyways, fellow says, comment that someone made, says Germany should be worried because of Ukrainian war probably coming up. Russia provides them with most of their heating energy. Yeah, and I think Germany is worried, and now you have a government which is probably a little closer to Russia than the previous one. It sounds like that. I don't know if that's true. But there are a lot of relations between Germany and Russia. And so the question is whether Germany is completely on board with the NATO philosophy. They might act differently if Russia happens to attack Ukraine, especially if Russia does not attack so openly. Maybe it's a little skirmish here and there, something that doesn't justify, um, severing all relations. So we'll see what happens. But yeah, that's something that's on the books right now. All newspapers are dealing with this subject. Okay, it's an important issue, I think. Okay, on the other side of the world, we have a similar situation. China obtaining TSMC fabs. This is Taiwan Semiconductor. Okay, probably the biggest prize that Taiwan has, in my opinion. And I expect important equipment would be sabotaged or spirited away if China invaded. Yeah, and I kind of agree with that. They can destroy it, they can take it away. Where they can take it away, it's not so easy to dismount all that equipment. Okay, or they'll take maybe the most important equipment, leave some of the less technologically advanced equipment behind. Who knows? They might even destroy the fab. All that might happen. It's part of the war tactics or strategy, right? And I'm sure some of that is being thought out already in advance if China invades Taiwan someday. Okay, but yeah. Says, I'm not sure that TSMC owns this technology. The issue there is that you can see the fab there, and I used to work in places like that, and they own it because they own the equipment, and they have the specs there to manufacture chips. So no, once you have the fab, that's more important in that sense than design, because design is done in the offices. And they can design chips in other places as well, especially if they have the blueprints right there for TSMC. No, the important part is the fab, the hardware. Okay, that's important because they have the equipment there. So yeah, unless they decide to take it away, remove it from Taiwan in case of an invasion, or they destroy it, I think it would fall in the hands of mainland China. So that's something you got to think about. If there is a war, which apparently is coming up, a lot of these countries have interests, Ukraine, in Taiwan, in the Middle East. So it might be a great year for war. It's about time we had a good war. I mean, right? Okay, fellow says about extinction. He says, when you introduce the word if into your propositions, then conclusions that follows becomes a prediction. If you don't explain the mechanism. I didn't explain the mechanism? I thought I did. But the guesswork based on if leads you to imagine possible scenarios. Okay, basically Bill says, this is what caused extinction of the dinosaurs. Okay, this is the mechanism. Okay, so I did give you a mechanism. Now project that to humans. Okay, can man elude the same mechanism? The same process? Right, good question. man cannot elude, right? That's my conclusion. Okay, we can safely say that someday humans become extinct. What is this reasoning? I understand what you're saying. Well, I don't know if you do or not. I mean, he says, what is this reasoning? And then he contradicts himself saying, I understand what you're saying, but then, does he understand or doesn't he? I have no idea. And again, the argument is very simple. If whatever happened to the dinosaurs, just to mention one case, we can go with the archosaurs or the amphibians, carboniferous, whatever. We can go with any era, okay, any epoch. And we say, well, what happened to them? Well, this is what happened to them, okay? Whatever it did, let's say we figured it out. Now we take that cookie cutter, right, and we apply it to man. And we find out through reasoning that we can't do anything about that same mechanism that killed, these animals in the past. Well, then, we have a mechanism of extinction. And again, it's got nothing to do with the future, with prediction. It's got to do with the fact that if we cannot elude that mechanism, it's a done deal. Okay? Again, I give the example of buffaloes running over a cliff or someone stepping over a cliff. Well, as soon as he takes that step, I'm going to say, if you take that step, you're going to fall down over the cliff. It's not a question of whether he's going to hit the ground or not. If he takes that step, he will fall. Okay, so it's a guaranteed thing. So if the premise is correct, if we accept it, if we concede it, then we have to conclude that whatever follows from that premise will happen. And so I don't know how else to explain that. It's not a prediction. It's got to do with mechanism. Okay, and so when people focus on the word prediction, say, oh, you're talking about the future, and they get lost. No, this is not about talking about the future and about the day that it's going to happen, predictions and foretelling and crystal balls, none of that. It has to do with mechanism. If you cannot elude a mechanism, the conclusion follows from that reasoning. So I don't know what else, how else to say that. Okay, moving on here, we have another fellow that says, Bill, why don't you, I think it's the same fellow, Bill, why don't you open a dictionary once and for all? Okay, I'll try to open a dictionary. I don't have too many of them, but yeah, I can think I can find one. Techno and logy, in other words, technology from the Greek. And he goes over the etymology of the word technology, where it comes from and all that stuff, which is totally irrelevant. Please don't do that anymore. Drives me nuts. Puts all these etymologies, where the words came from. Nobody cares, especially when none of the words in the ordinary dictionary can be considered to be scientific, especially the keywords. Okay, so if technology came out of your ordinary dictionary, irrelevant. And again, we don't rely on authority, we defend our definitions. So if we have an irrational definition, we don't care what the etymology was or how it's been used in the past, we censor it. We say something's wrong with that definition, we have to revise it. That's the way it works in science, okay? We don't use irrational definitions simply because of authority and tradition. That's the issue. Okay, and it says has its object the application and use of technical, okay, and in broad sense, that is to say of everything, okay, it covers everything, including the word knowledge and science, etc. Yeah, this is the problem. Technology has nothing to do with science or with knowledge, okay, and so, to put everything in there and say, I got it from the dictionary, you haven't said anything. That can be applied to the solution of practical problems, to the optimization, etc., etc., etc. Okay, no, that's not a definition of technology. Okay, let's put a rational one. Okay, and it's got to do with two words. One is invention, and the other one is innovation. Today, these two words are essentially treated as synonyms, even by the patent office. Okay, and so we have to distinguish innovation from invention. Invention has to do with objects, with things, with tangible things, and innovation has to do with ideas, with concepts. Okay, and so you can patent an innovation at the patent office because again they haven't defined exactly what they mean by invention and innovation. As far as the patent office is concerned, they're synonyms. And now we have to distinguish those in physics, because physics deals only with tangible objects out there, with in everyday physics, right? With especially if you're going to do an invention, it better be seeable and tangible. Okay, and so here it is. Let me put it over here so you can compare it. Okay, innovation, implementation of ideas, introduction of new methods. What is an invention? A new tangible gadget. Okay, so these two words are not synonyms. Invention has to do with objects, innovation has to do with concepts. Invention has to do with a manufacturing economy, innovation with a service economy. A computer program is not an invention. Even though the patent office might accept it as an invention, it is not for the purposes of physics. We have to distinguish these two words, okay? And so the patent office, they might accept it and consider them synonyms, but we don't, okay? So when people equate invention with innovation, they're talking about ordinary speech, means that they simply got it out of the dictionary and they copied and pasted, which is what this fellow did. He just copied and pasted. He didn't even analyze what he was copying or pasting. He just copy paste. My God. Well, it says, why did the Neanderthals have sex with sapiens and not produce children? Yet they are of the genus, of the order of the primates, etc., etc. Okay, he said that we all descend from the same tree, essentially, right? And they did not have a human genome. No, because they were not humans. Okay, are gorillas the same as, they have a human genome? And no, the gorillas do not have human genome. Okay, why, in your opinion, nothing came out? Well, again, because they were so different. If you have sex with a gorilla or with a chimpanzee, I don't think anything good will come out of that. No, nothing will come out. In fact, they tried the human Z and nothing came out. So why would something come out of Neanderthal with humans, or with, for example, Homo erectus and humans? Why would something come out of there? Okay, you have to specify or find out why. But more importantly, how would they meet in the wild? Why would a human, go out there into Neanderthal territory and suddenly decide to have sex with this other species? Okay, try it one day. Just take a lion and take it over to, tiger territory or vice versa, and see if they all decide to share their wives or whatever. And so do not tell me species, because there is also a proposal that Neanderthals were a subspecies of the sapiens. So nothing certain. How rational is it for your science to say species? Well, yeah, you have to define the term species, and there we try to do that. Viable breeding. Okay, that's what species is essentially. Okay, so if you can have viable children, offspring with someone, that someone is part of your species. Now, it means you have to have something come out, okay, first of all. But if whatever comes out is a hybrid, and that hybrid is sterile, then they're not of the same species, or they're at the borderline of being the same species. Maybe next time they have success, maybe next time they don't, okay? But yeah, you need to define the word species, because that's what interbreeding has to do with. You're saying, okay, if they interbreed, will they have successful children, viable children? If they do, then they are of the same species. Their genes, their makeup is not so far apart. Okay, and the question is whether the Neanderthals and humans were even similar after 500,000 years of separation or so. We don't know exactly how long they were separated, but more than separation, the Neanderthals grew up, evolved in Arctic Europe, and they came out of the apparently, right? They came out. No, they didn't migrate there. The guys who migrated there were, if anything, their ancestors, which were the antecessors or the Heidelbergs, which didn't migrate there either, because they came from the Homo erectus, who migrated there maybe anywhere between 800,000 and 1 million years ago. So those were the parents of Neanderthals. And by the time we get to the Arctic, which this Arctic weather, there was Northern Europe, we're talking about maybe 40,000, I'd say even less, 35,000 years ago. And so when we got there, I don't think there were any Neanderthals. That's one issue. The other issue is that if there were any Neanderthals still alive, they were nude. They invented no clothes. Neanderthals had no clothes. Here we were, in this freezing cold, we were, wrapped up. And so here you see this Neanderthal looking at you, and you looking at them. He sees you with all these clothes. He doesn't know what you are. What did you put on? So yeah, this is my take on that. Is Neanderthals and humans were so far apart, and they had no common language. They had probably no similar sense. You gotta smell them. Okay, I'm sure each one marked their territories. I'm even saying that if they had, again, different weapons, somewhat different cultures, because by that time the Neanderthals were sedentary, whereas the humans are Cro-Magnons, right? They were moving into their territory. They were nomadic. So there were a lot of differences for a human to sleep with a female Neanderthal or vice versa. Okay? I don't think it ever happened. And here's another issue. Fellow says, compare or make a similarity with the results of Calhoun's experiment with a human species. No. Why? Well, he says, comparing 8 mice against 2 humans, for example, Adam and Eve, because in the case of Calhoun's experiments, we had 4 pairs of mice, and they immediately, each one took their wives. Each one of the male mice took their wives and went out and squatted some territory and started having kids. Okay, and here they're talking about 2 humans like Adam and Eve. Are we the same thing? We came out of Adam and Eve, apparently. But it says, given perfect living conditions, man adapts to the environment and survive. Okay, everything they need, but who gives us everything we need? In other words, the mice had everything they needed. They were protected from cats and other predators. Okay, they were inside this place. They couldn't get out. Okay, and they just multiplied in there. That's essentially the experiment. And he's saying that we gave them everything. We gave them food, we gave them water, and we gave them, nesting material. So they had everything they needed in there. They didn't have to go out and look for it. And he's saying that humans are not like that. In other words, regular humans, like in the cities, where pretty much can leave the city, come back in, and do whatever we want. Okay, so he says, how similar to mice are we? Well, I think we are quite like mice, beginning with the fact that we're part of the mammal world, both mice and humans. Okay, we all come from mammals, and we all belong to the mammal world. Okay, it's because of the way we have children. Okay. And then he continues, he says, is the Calhoun experiment comparable to planet Earth? Well, in a way it is, and for what he says next. He says, the mice will surely have tried to escape the Earth. Is it a perfect cage where humanity has no escape? Yeah, I'm saying that the Earth is a perfect cage. We cannot escape Earth. Okay, we will never colonize another planet. We'll never leave. This is it. We are born here, we die here. So in that sense, yeah, we are very much like these mice. We're trapped on Earth. We don't have the freedom to leave. Okay, we can run an experiment, go to the moon, maybe go to Mars, and that's about it. Lab experiment. That's fine, but that's not evacuating Earth. Okay, or forming a colony somewhere. And are we humans also an experiment? Yeah, in a way, I think we're an experiment of Mother Nature. Okay, so you can look at it that way. Okay, we're our own experiment. We're experiment with ourselves. Okay, we go out there and we do experiments like go to the moon, and we go to Mars maybe tomorrow, and we go and come back, and then we stay here. I don't know of anyone who lives on the moon or in Mars yet, and I doubt there ever will be, because extinction will catch us with our pants down. But a fellow insists, he says, hey, what if we go to the moon? I like this one. Says, the conquest of space, to be called more properly black sky, is one of the most interesting challenges of humanity if we did not waste time and money in developing military technology that can self-destruct us, totally eliminate us in an extinction of the species. I would already be on vacation on Luna Hotel with a view of the Sea of Tranquility and our blue pearl in the background. So I guess there he is. He thinks he's going to be on a hammock, near the beach. The Sea of Tranquility and with the Earth in the background. Yeah, sure. I think a lot of these people watch too much Star Trek. That's what it is. They think we can go to the moon and just live there, And they have this in the back of their minds that, this is possible. It's never going to happen. That's all to keep your attention. And people say, oh, we're going to go to Mars. We're going to build, our station there, and we're going to live there. We're going to expand through Mars. It's never, ever going to happen. If anything, the best that will ever happen is we send a few astronauts to Mars. Could happen. I think we have the technology to do this. Okay, send a few astronauts to Mars. Maybe even put a station at some point. And whether it will ever be inhabited, I doubt it, because they would have to supply it constantly with everything from Earth, and each expedition will cost millions. Right now, I think the Earth doesn't have enough money in the treasury for all that expense. No, if anything, we go to Mars, step on it, come back, and never go back again, just like we did with the moon. There's no reason to go to the moon. There's no reason to go to Mars. There's no military reason to go to Mars. I mean, you can develop the technology to go to Mars. That might help the military. Yeah, and that could happen. But going to Mars and then staying in Mars because that's going to help us in some way in a war here on Earth? Absolutely not. People are thinking in terms of what they watch on in the movies on TV. They say, "Oh, we're going to be shooting these laser guns," or maybe they've been playing too much with these paint guns on weekends. My God. Okay, here we have Paul says, also with the moon. He says, the moon landing. I believe in space and science and a globe Earth. But to me, it's abundantly clear that the U.S. government lied about going. It was a dirty trick played for propaganda and to save face against the Russian program. Some people don't believe that we went to the moon. And I guess, you can take that on to anything else. It's like if you don't experience it yourself, you won't believe it. So JFK never existed. He was never killed. Okay. Lincoln never happened. Napoleon never happened. Because I wasn't there to touch Lincoln or Napoleon, or Caesar, Julius Caesar. So if I'm not there, then it never happened because, I wasn't there. So I have no experience, no hands-on experience with it. And so I have no hands-on experience with the moon, or with these people going to the moon. So it never happened either because I wasn't there. And the nuclear bombs never happened because I wasn't there, and so on. And people think that existence is a question of, having touching and seeing. So the ball that they're playing soccer with on the other side of the planet right now doesn't exist for me because I'm not there. I haven't been able to touch it or see it, so it doesn't exist. That's their reasoning. And so, you start to wonder. Yeah, you have to take some things for granted, and that's that, what we do is what the ancients used to do also in their cultures, which is pass from one generation to the other some of the stories that their folks passed on to them. And so they took a lot of these for granted. A lot of them were, mixed with mythology and so on. Okay, but today we've gotten a little better on that. Also, we got better at lying, but it's harder to lie with people who have already some experience with lying. Okay, so, you cannot say, well, JFK never happened, and Roosevelt never happened, and I don't know, Lincoln never happened, Washington never happened. You can't say that because, these things have been passed on from generation to generation. And what are we going to say? These people did not exist simply because I never saw them, never touched them. Okay. And so here, this one, maybe he didn't see men go to the moon. And I don't mean through the TV. I mean, like, he wasn't on the moon to see them land there. So uh, we're not supposed to believe that humans went to the moon simply because of this, because I wasn't there. I mean, what's the reasoning? And so here I can only provide a couple of, off the top of my head, by the way, okay, because I think we did have the technology to go to the moon without any problem, okay? And these are other questions he might ask himself. The Soviets did not question the moon landings. You would think that if the Soviets uh, didn't believe it happened, they would have said something, say, well, no, you guys said you went to the moon, but it really didn't happen. And then the question is also goes in reverse. The Americans could have said, well, Gagarin and Tereshkova and Laika, the dog, those were all hoaxes. Russians never went up there. They could have said that, right? Because, even the United States accepts today that Gagarin was the first man to orbit the Earth. And Tereshkova, the first woman. And so, why would they concede such a thing? It would have been much easier for the United States to say, well, no, that didn't happen. The Russians are lying. I mean, we got to take it in both directions, okay? And the same with the Russians. The Russians should have questioned the moon landings and say, well, that never happened. And that's not the case. The Russians accept that the moon landings did happen. They were worried because, all this technology was developed in great measure. That was one of the reasons they were worried. So no, the Russians accept that the Americans went to the moon, and therefore this notion that it was just a dirty trick for propaganda. I don't think the Russians bought it, the propaganda. They knew it was real. And then you have so many missions. I mean, you're talking about at least 60 years since the 60s, okay? And you're saying they're all fake. Nobody saw anything. You can go to the space platform there in Florida and watch the rockets go out. Okay, and yeah, you can film them. Take your camera, take your telescope, and you can watch it go out into outer space. So we haven't gone into space. We haven't put satellites out there. Why wouldn't we go to the moon if we have the ability to go into orbit? Okay, so these are other things you got to ask yourself. And then Chinese recently, they started their space program relatively recently, but they don't go to space either. Again, you got to go deeper. You can't just pull one thing out of nowhere and say, well, I don't think they went to space because it was just for propaganda. That argument can easily be turned around, okay, and thrown against you. So, all I can tell you is, yeah, we did go to space, to the moon. There was no purpose to go to the moon in the first place other than to develop technology. But once we went to the moon, or at least the Americans went to the moon, they found no further reason to go to the moon. Why would they go to the moon to do what? Plant potatoes? I mean, you know what it costs to send someone out there, just insurance costs? And then, when you bring them back, you send another crew, and you got to keep feeding them. I mean, assuming you create a station on the moon, right? A permanent one. You got to keep feeding them and taking air and water and all this stuff up there. What for? What are they going to do out there on the moon that they can't do, like, for example, with a Skylab, an orbiting lab, which is much closer by? So again, there's no reason to go to the moon. That's why we haven't gone to the moon again, because what are we going to go there for? Just to pull some rocks, see the dark side of the moon and say, oh, it looks pretty, take a snapshot and bring the picture back? No, we'll never go to the moon again for any real reason. Maybe just to develop technology, that's it. But the moon itself or Mars itself, there's no purpose. None whatsoever. So it'll never happen because, again, there's no reason to go there other than to say we made it once. We touched base, came back, we did it, let's celebrate, pull out the champagne bottle, and that's it. That's where it dies. It won't go beyond that. Okay, fellow says, Morals, the god of doom, has spread his spirit of impending doom. Whoa. Who drives mortals to their deadly fate? And Morris has nothing but pessimistic view for humanity. And there's Morris at the bottom there. He's the Greek god of fate, of doom. Again, people think that when I'm doing all these predictions, as they call them, it's not predictions. I'm talking about mechanisms, and they focus on prediction. They think I'm an astrologer or something, with my crystal ball and saying, "Oh, on the 1st of July of the year 2029, we're going to become extinct." No, that's not what I'm saying. I'm saying there's a mechanism we cannot avoid, and it's the mechanism that causes all mass extinctions. And that's a little different than saying, I predict. This is not Nostradamus. Nostradamus, okay, he just got it on the top of his head. I'm not doing that. I'm saying, look, I've got a mechanism that is foolproof. You can't beat it. No matter what you do, you can't beat this mechanism. The mechanism is the collapse of the global economy. We can't do anything about it, no matter what we do. And it comes to the subject, it's coming up in a couple more of the comments that people made. Here's the first one. Fellow says, Bill, economists are saying that the economy is doing really good right now, almost too good. This is why the supply chains can't keep up with demand. Deliveries are falling behind, partly because some people don't want to work, and I guess they're not paying enough to get people to go to work, and so deliveries are falling behind, and demand is I guess, overpowering supply, right? I have noticed from a personal aspect that the big box stores and other stores, chain stores, are very much busy all the time. I don't know what to think of this. Yeah, all I can tell you is that, first of all, you got to look at the big picture, macroeconomics, okay? And when I'm saying, and not micro, you're talking about microeconomics. And I'm saying macroeconomics trumps microeconomics. All these people who are, I call them narco, they're called the narco capitalists. I call them narco caps. Okay, these folks are typically micro economists. They don't think about the macro world. Okay, and what I'm saying is macro trumps micro. In other words, you can't develop yourself, small guy, in a world that doesn't develop itself. So if the world is shutting down because macroeconomics is falling apart, it doesn't matter if a company here and another one there does well. Okay, so I overrule microeconomics with macroeconomics. What's happening to macroeconomics? We're moving into the service world. Services is unemployment. That's what it is. Another word for unemployment. When you do services, all you're doing is passing money around. Until that money goes into building something or something that's tangible, could be food, could be a building, could be a car. Until that translates into something like that, there is no growth. All you have is pushing money around. I give you money because you signed a contract. The other guy gives money to the other fellow because he's in the insurance business. He insured the operation. The other guy puts it in the bank, and the bank controls the money and helps people, manage their accounts. What is all that? Nothing. All we're doing is passing money around. What does a programmer do? Nothing. All he does is play around with a computer, change some programs there, and for doing that, he gets money. What did he do? Nothing. He created an abstraction. Until all that turns into something solid, we have no growth. Growth has to do only with tangible things. Physics, real physics, not with philosophy. And when, like I said, when you're up there with God and looking down at the planet, what do you see? Well, what is growth? Growth is real growth. Growth of that which you can see, maybe touch, right? You see roads, buildings, you see fields of corn, houses, cars, ships, airplanes, whatever. You have growth. But we can't see the promises. We can't see what the insurance company promised you or the contract or whatever. All that is fake. And so when you move into the service world and abandoning the manufacturing, the tangible part of our economy, you go into unemployment. And so that's one issue for this fall. The other issue is that I don't know how many countries are doing well. A lot of countries are not doing well, and I think just like within a country, you get the rich getting richer and the poor getting poorer. That's a trend that's been going on for quite a while. It happens also on a worldwide scale, where you have the rich countries getting richer and the poor countries getting poorer with respect to them. That's also happening. And the question is, how far can the rich become rich and the poor become poor when the rich depend on the poor? So keep all this in mind. The macro is important. Don't look at, oh, I saw the store sell a lot of stuff and the numbers are going up, as I showed you just now with the graph. What is it, 2020? They were expecting a big rise, and they didn't expect this COVID thing to come around. So the predictions were wrong, and they had really negative growth during 2020. Compared to that, 2021 was, positive. Why? Because they went down so low that any improvement over that previous year was, positive. So they had like 5% growth. But was that real growth? No, that was growth with respect to the previous year. I don't think we got back to 2019 yet. So keep that in mind. There's a lot of stuff going on. You can't treat that so superficially. Okay, you got to look at it in more detail. Okay, and final issue, Fall says, our main reason for extinction is stupidity. We have screwed our culture up to the point that some purposefully try to degrade it further along with morality. Others hate our traditional culture and want it eliminated, which will destroy everything. Well, again, people get into politics, and that's what they want to talk about. Here we try to talk about physics, meaning mechanisms, meaning theories, meaning explanations. Okay, we have to explain a mechanism, and the extinction theory has to do with the mechanism, the causes of extinction of man. And so that's got very little to do with the rich taking advantage of the poor. That's always happened there. Ask Marx. Karl Marx would have given you a sermon on that. And, that's always happened, where the rich took advantage of the poor. One human taking advantage of another. That's always happened. That's not the issue. The issue is, can we do anything about extinction? Can the rich, with all their power, all their might, all their money, can they do anything about extinction? My answer is no. Okay, so let's move on here. Let's go with the neutron. Okay, and the other day we started with this fellow. His name is Peter Peregrinus. What did he come up with? Well, he came up with positive and negative. I'm sorry, not positive. He came up with North and South Pole. He was the first guy to propose, as far as I know. I don't know of any other some of anyone's before Peregrinus that came up with this north and south. If you do, please let me know. I really like to know. But as far as I know, this is the first fellow that talks about north and south pole of a magnet. And in a letter he wrote to a friend, which has been turned into a book, he just says, look, there's the north and the south pole. One points to the north pole, the other one to the south pole. Okay, and he showed his friend in the letter, he explained to him how to discover which one's the North Pole, which one's the South Pole. Did he explain how a magnet works? Absolutely not. Okay, and so a couple centuries later, a few more than that, more than a couple. Okay, we have this fellow, and his name is Ben Franklin, and he came up with a notion that we use still today, and that's the negative and positive. Actually, he liked to talk more about the plus and minus. His theory was essentially that there was electricity was some kind of fluid, and either you had it or you didn't. And so it was like a plus when you had it and a minus when you didn't. So this is where the notion of positive and negative originated. Okay, and yeah, these fellows just gave labels to something they did not understand. And it turns out that here we are hundreds of years later from Peregrinus and at least a couple hundred from Ben Franklin, and they still don't know. The mathematicians still haven't figured out what north and south pole mean or positive and negative mean. Okay, and so here we are, positive and negative, north and south pole. What are we referring to? Well, specifically in the case of what we're going to deal with today, the word charge. Okay, we have positive and negative charge. What in the world is positive charge, negative charge? Anybody have any idea? I mean, look it up in your quickly, in your physics textbook. Maybe you can enlighten me today. Okay. Okay. So what happened? Well, we had only positive and negative for quite a while, at least 100 years, I would say. And Joseph Thompson, okay, English fellow, he eventually zeroed in. There were many people working on this, by the way. They exchanged ideas. He finally came up with a notion that there was something called an electron, and this was assigned the so-called negative charge. Okay, so the electron now was the negative fellow. Okay, and a few years later, almost 20 years, Rutherford, he ran his backscattering experiment, and he zeroed in on this notion of the proton. That was given the positive charge. Did any of these two fellows know what negative and positive charge means in physical terms? The answer is no. Okay? Neither one, even to this day, have no idea what negative and positive charge mean in physical terms. These are mathematical terms. So we come to the neutron, which has no charge at all. So what we need to figure out today, among other things, is what is this absence of charge that the neutron has or doesn't have? I don't know which way you want to phrase it. The neutron doesn't have charge. What is it that it doesn't have? It's like, I have 10 cents and a dime in my pocket, right? So if I don't have it, well, I have the absence of a dime. But we know what a dime is, because when I do have it, I can say this is a dime and I show you a dime, right? Can we do that with charge? Can I say, well, I have the absence of charge? Okay, what is it when you do have charge? What are you going to show me? Okay, so charge is not a thing, but as we've seen in the last couple lectures, these people are moving charges. So when you talk about moving charges, if I say, well, I'm going to move this little ball, right? People say, okay, I understood it. You're moving the ball. You're moving it from, in my case, left to right. Okay, so I'm moving the ball from left to right. I can say that because, I have something for you to see and touch, But when you say charge, what is it that you're moving from left to right? How did charge move from left to right? And how about no charge? Absence of charge. What is it you're moving from left to right? Gets scary after a while, okay? Because you don't know what these people are moving. Okay, so what was this? How did we come up with this notion of the neutron, which is a so-called particle that has no charge, okay? So it's different than the proton, different than the electron. What is it like, okay? That's what we're going to try to reach here, okay? Well, this fellow, his name is James Chadwick, and in 1932, he did a couple of experiments and published a paper in which he said, I discovered the neutron. What is a neutron? Well, it's kind of like the proton in size and mass, etc. But unlike the proton, it has no charge, and it's inside the nucleus of the atom. Okay? Most atoms. The only one that doesn't have one is the hydrogen atom, unless it's a deuterium or tritium. Okay? Okay, so he comes up with this neutron, and how did he come up with this? Well, they had until then the idea that there was something inside the helium atom that didn't make sense, because it turns out that the helium atom had two charges, two positive charges, two negative charges, but a helium so-called weighed not like two hydrogen atoms, but like four of them. Okay, so here's the rundown of how they came up with this notion of the neutron. The helium atomic number was 2, but the mass number was 4. Okay, so helium had two charges like two hydrogen atoms, but it weighed like 4 hydrogen atoms. Okay, this was the problem. So they had to figure out what was going on. How come it only had 2 charges if it weighed, a lot more, twice as much as what it should have weighed? And so what Chadwick did, he bombarded beryllium with particles, okay, with alpha particles, and he concluded that the radiation ejected from beryllium was a neutral particle having approximately the mass of the proton. Okay, that's how this all went. Until then, they thought it was photons, neutral photons, uncharged photons that were causing this. And he said no. When he did his experiment, he says no. A photon cannot move. The particles that we're removing from the atom, the beryllium atoms that he was bombarding them with. He said no, it's got to be something massive. And he figured out that no, there's some other particle in there that we missed, and they call that particle the neutron. Okay. Again, a lot of this was math. They never saw a neutron. They just said something's happening in there. These are the calculations. From those calculations, they inferred that there's got to be another particle. And because of the situation, they said, well, this particle weighs as much as a proton, or just about, but it doesn't have charge. And that's the only way we can explain the helium atom. Okay, so this was the reasoning. This is how they came up with the neutron. Okay. Okay, so, but it turns out that, like I said the other day, the proton is not the only particle that is positive. Okay. There's a couple more, and I covered them the other day. I'll just go quickly here. Proton is made of 3 quarks, and it's so-called positively charged particle. Okay, but then you have also the positron, discovered by Anderson. Okay, and it's that little trace there, because the positron, it's not like we have a particle and say, here's the particle. I can't show you a positron. It's essentially has, I guess, the size of an electron, which is no size point particle. Okay. The only difference is that positron has a P plus. An electron is positive. That's essentially what the positron amounts to. And all they said is it's that trace there. Okay, that's how Anderson proved it, Carl Anderson, and got a Nobel Prize for that. Okay, so all we know about the positron is a trace. They call it a particle, but it's a trace. That's all we have. Okay, and then we've talked about the hole, the fact that, you have this hole created when an electron leaves its atom. So it leaves a hole behind, and void. And so as the electrons move to in one direction, the holes, you can conceptualize holes moving in the opposite direction. And here you have a picture of that. Okay, essentially you can see the electrons moving in one direction, and the holes, positive ones, because the electron is negative, the holes are moving in the opposite direction. Used significantly, or quite a bit, in semiconductor processing. I dealt a lot with this. And there you see the analogy down at the bottom. You move the little 16 squares, one of them to the side. What you leave behind is a hole. So instead of looking at the white boxes, you look at the holes they leave behind, and that's more or less the idea of the hole. Okay, so what's the issue? The issue is that these people are talking about positive particles aside from the proton. We have the proton, the positron, and the holes, at least. Maybe they'll find some more out there, and there are, yeah, for sure. But those are the main ones. But it turns out that we also have many uncharged particles, not only the neutron, okay, and here it is, okay. Neutrons, uncharged, but we also have neutrinos, photons. The photon is uncharged. And you say, well, why isn't it charged? Why can't, in other words, you heard maybe that gravity pulls on light, meaning it bends the beam. Could that be charged? I'm sure the electric universe people, they would probably agree that if all this is electrical and gravity is electrical, then if it's true that a beam is deflected by gravity, then it's because, it has the opposite charge to gravity. Right? we could conceptualize that photons have charge, but right now they say photons have no charge. Neither do gluons, the little particles that keep the quarks from flying away, inside the proton and the neutron. Okay, so the gluons are also uncharged. So the pions, the kaons, the Z bosons, the Higgs, discovered a few years ago, right? They say the Higgs bosons, those are uncharged. So are the gravitons. Okay, none of these are charged. In other words, they're not electrical particles according to quantum mechanics. But on the other hand, neutrons are. In other words, they're uncharged, but, well, we'll get to that in a second here. They're uncharged, but they are charged. And let's find out how they figure out that the electron is charged first, and what does charge mean in mathematics. Okay, mathematics, or mathemagics as I call it. Okay, they have this fellow Robert Millikan, and he came up with an experiment to determine what the charge on an electron is. It's known as the oil drop experiment, 1909. And what he did, he let some oil drip through an orifice there, and then was able to suspend it in the air. Okay, and so he essentially, he had an electric field from the top, pulling from the top on the particle, and at the same time it had to fight against gravity. So all he had to do was figure out, calculate, the ratio there between gravity and the electrical field, and he was able to determine the charge on an electron. And today we use the charge on an electron and also on the positron, by the way, just opposite signs. What is it? 1.6 times 10 to the minus 19 coulombs. Okay. So how did they calculate, or how did they determine that the proton and the neutron one has charge and the other one doesn't have charge? How did they determine that? Okay, and here you have, again, mathematics. That's all it is. Okay, what they do is they take the proton, which they eventually zeroed in, and they said it's got two up quarks and one down quark. That's what the proton is made of, whereas the neutron is made of two down quarks and one up quark. And so what they did is they gave these quarks charges, but they gave them fractions of charges. So they took like the up quarks there, and they have 2/3 charge plus 2/3 charge minus 1/3 charge. Well, that's 4/3 minus 1/3 gives you 3/3, meaning 1. And in the case of the neutrons, they took the plus 2/3 of the up quark, and they subtracted 2 1/3 of the down quarks, and that gave them 0. So it was a mathematical calculation, baby stuff, really, kindergarten stuff. And they say that's what why the proton has charge, okay, and why the neutron does not. And the question is, how do you do that with the electron? Because the electron is just given one charge, right? 1.6 times 10 to the minus 19 coulomb. That's the charge on the electron. But the electron is not made of simpler parts. That's the official version. It's a point particle. It's zero-dimensional, if you're going to go with a notion of point particle. Okay, and so how do they do this math with the electron? Okay, so this is the issue. They did it for the proton and the neutron. They get Nobel Prizes for this stuff. They say, oh, you figured it out. 1/3, 1/3, 1/3. We did it with quarks. Okay, so this is how, again, what I want you to know is that it's all math. It has nothing to do with them going to the lab and proving or seeing, observing with the eyes what really occurred there. It has nothing at all to do with that. They just took the proton and said, why does this one have positive charge? Why does the neutron have no charge? They say, oh, I know. We divided it in 3, 2 up quarks, 1 down quark, 2 down quarks, 1 up quark. We got it made. We can explain charge. And how can you explain charge if you don't know what charge is? What do you mean by charge? Is it a physical object? What is it that the neutron doesn't have? Once you did all that calculation, ended up with 0 charge. What is it that it lacks? What is it the proton has? Just a number? Coulombs? Is that what a charge is? Okay, so here's what the proton looks like today, okay, because of that, okay. It's got these 3 quarks, okay, and they're prevented from leaving that globe, that sphere, by the springs. They're all bound by springs. Those springs are known as gluons, which is allegedly a particle that goes back and forth between these three quarks, okay? Two ups and one down. And so the question is, what are those springs? Why do they put springs in there? Because you don't find them in the standard model. If I go to a standard model and this is gluon and I see a spring, I say, okay, very straightforward. The gluon looks like a spring and it's binding two quarks. I understand that. We all understand that. Okay? Very simple. But you go to the standard model, you don't see any springs, no gluon springs there. Shows up as a ball. Supposedly, quark sends gluon to the other quark, and they just trade trade gluons back and forth. How does that keep them together? How does sending little particles keep two quarks together? And it turns out that these particles go in a spiral. That's why they ended up with this spring, because they put what you're staring at when you look at a spring, gluon spring, what you're really looking at, according to them, the mathematicians, is the spiraling of a particle. So that's a trace that you're seeing there. But they always put the spring, and people say, well, I understand what's happening there. The quarks don't fly away because they're bound by the spring. No. What you're seeing there is the trace of a gluon in a spiral manner going from one quark to another quark. That doesn't explain why the quarks don't fly away. And the same with a neutron. That's a proton. Here's the neutron. Okay. So you can see them side by side. One has two ups and one down. The other one has two downs and one up. Great. And both of them have these gluon springs, which are not springs, which are the motion, the spiraling motion, okay, of particles known as gluons. But, what we're concerned about, because there's this other issue here, and it's this. Here you see them. We want to know what those spheres are that keep, that they always draw, and that keeps, these quarks from flying away. Here are the quarks. They don't fly away, okay? And why don't they? Well, they say because this gluon spring holds them together, which is not a gluon spring. That's the first problem. But the second problem is, even if you remove the gluon springs completely, the question is, what is that sphere in which the quarks are trapped? And so let's remove all that stuff. Let's remove the gluon springs. Let's remove the quarks. And now we have just the spheres. What are those spheres? What material are they made of? What is that? Why do they put them in there? This is the question you have to ask, okay? Because they put them in by hand, but just to show that the proton and the neutron are spherical particles. But what are we staring at? What is this sphere? And so, yeah, that's all put in by hand. We have no idea what they're talking about when they put them in there. They never identify that. They just put the gluons together with the quarks and this unidentified sphere. Because the whole thing is the proton. The whole thing is the neutron. It's the three quarks, the gluons, and the sphere. What is the sphere? Why did they put it in there? Why don't they get rid of the sphere completely and just put the gluons and protons and say, well, this is what a neutron, the gluons and quarks, and this is what a proton or a neutron look like. It looks like two balls tied by springs. Three balls tied by springs. No, that's not what they do. They put that sphere in there to make it look pretty. Okay, and it's misleading because people say, well, I understand that. They can't leave the quarks because they're bound by the sphere. So it's misleading because they never identify what that sphere is. Okay, here we have one of the things that keeps them busy at night, which is this neutron beta decay. Also, there's a proton that turns into a neutron, but here we're going to look at the neutron turning into a proton. And what it is that neutrons have the ability to turn into a proton plus an electron and an antineutrino. Okay, and so if you put those together, it matches a neutron. And the reason for that is, again, we're doing math. We're not doing physics here. We're doing math. They're saying, look, if you take the neutron, it weighs or has the mass, right, of all these three particles when you put them together. And so it's just an accounting procedure. They say, look, a neutron weighs a little more than the proton. Well, how much more? Well, it weighs like a proton, an electron, and an anti-neutrino. Okay, that's what they're saying. And so is a neutron really neutral? I mean, does it have no charge whatsoever? You can say that it's a blend of positive and negative charge. That's what a neutral neutron is allegedly. In other words, it's got a blend, a mixture of positive and negative charge that cancel out. One has a positive charge, the other one has a negative charge. You take the positive value, which is positive x minus x. What does it give you? 0. So so this is an accounting procedure. It's got nothing to do with reality. It's got to do with, this is the way they calculated, how a neutron doing its beta decay turns into a proton and an electron. Something was left over and they said, we'll call that the anti-neutrino. It's all accounting, math. That's all it is. Nothing related to physics. They have no idea what any of these particles look like or whether they even exist. Okay, they have no idea whatsoever. They've never seen one of these particles. They haven't seen a hydrogen atom, which, when you look at it, it's a solar system according to them. And you have a very tiny proton in the center, and this electron is miles away. Okay, it's if you were to do an analogy, you would say maybe it's like being the center of a football field, and the electron is on the outer perimeter of the stadium. You have a little dot in the center, and the electron would be out there. And so if that's the atom and we can't see that, certainly we can't see the little dot in the center called the proton or the neutron, right, which are approximately the same size according to them. And for sure we have never seen an electron, not to mention an anti-neutrino. Okay, so none of this has anything to do with physics or with them actually seeing in the lab, observing, the word observe, right, any of these particles. They've never seen one of these particles. Okay, so all it is math, and that's what beta decay is. Essentially, it's an accounting procedure, and that's how they discover new particles like quarks and anti-neutrinos. Okay, what's the rope model? Okay, and so that you have something to compare it against. Okay, here's our neutron. Okay, and give it a second here, you'll see what happens. All ropes in the universe supposedly crisscross somewhere in space, here, there, and everywhere. Okay, so we should have many cross points for ropes across the universe. All atoms are physically interconnected. So not only is an atom connected to another atom, and those atoms are made the proton of threads coming from every rope in the universe, and the electron is made of threads that curve around and encapsulate the proton. But then those ropes themselves have to crisscross somewhere in space somewhere. And what we're saying is that's what the neutron is. And there I drew around it approximately the same size as what the atom is, the hydrogen atom. That's why the neutron weighs approximately the same as the hydrogen atom. So I'm saying that neutron is simply a different configuration of these same ropes. Okay, and here we're going to see them side by side. Here's the proton and the neutron. Essentially what we're seeing is the atom against the neutron. Okay, there you see the proton and the neutron. How are they built? Well, in the case of the proton, it's made of all these threads coming from every rope in the universe. And right at the center there, okay, you see the proton star encapsulated by the membrane, the electron membrane. In the case of the neutron, it's only just the ropes, and I drew the approximately size of the perimeter of the atom so that you can get an idea why the neutron has approximately the same mass as the hydrogen atom or as the proton. Okay, so this is the proposal. Okay, and in the case of beta decay, assuming it happens, because we cannot put our hand in the fire for the beta decay, but we're going to show you beta decay. Okay, and what you're seeing here is that the proton opens up and turns into the ropes because the electron membrane essentially comes into the atom and comes out of the atom, goes back and forth every 15 or so minutes, which is what they say happens spontaneously with free neutrons out there. Okay, and so here you have it. You have essentially, the proton star and the electron membrane that essentially comes out. One of the threads comes out, okay, and forms this peripheral membrane that encapsulates the proton. Okay, so we have an explanation under the rope model of how beta decay could be occurring, assuming it happens, because again, we're relying on what these people say happens in the lab, what they observed, that a neutron spontaneously turns into a proton and an electron. Well, there we have it. The electron is that membrane around that encapsulates the proton star. Okay, so this is the notion. We make it with the same material that makes up the atom. So if beta decay happens, we say we have an answer to that question as well. Okay, let's go with our conclusions. And here we have them. I hope. Where'd he go? Well, all the way to the bottom. Let me get him up here. Quantum mechanics has no idea what a neutron looks like. So we can't really give you a picture of the neutron because they have no idea. All it is math, no physics. Okay? Hume has no idea what charge is in physical terms. They have no idea what no charge means. In other words, what a neutron no charge particle is, what it looks like, what would it be different from a proton. Okay, just a mathematical calculation, that's all it is. No physical object called charge, and charge is a mathematical concept. Okay, so all they did was put a value there. Okay, they're saying one has this value and the other one doesn't. What is it that it has? We have no idea. Okay, so neutron equal no charge. There's no physical meaning to it in quantum mechanics today, in mathematical physics. So again, are they doing physics or are they doing math? That's the question you should ask yourself. And the neutron charge is constructed with plus and minuses. In other words, the neutron, the absence of charge, the no charge, is simply a mixture of proton with electron, and they don't know what positive or negative is, but when you put them together, you get no charge, meaning you get negative x plus x, that gives you 0. That's all they're saying. It's a mathematical calculation. We have no idea what it means physically. Under the rope model, we're saying, yeah, what we have is the electron membrane can fold in and continue as ropes. And then at the same time, it can open up and form the atom. And so it can do this back and forth, just roll and unroll one of the threads going in, so it continues as a rope and then comes back out. Okay, so it can do that every 15 minutes according to the beta decay process. They say it occurs in free neutrons that are not part of an atom. And so we have an explanation if that is what occurs. Okay, so no math, it's physics. Okay, we have a picture, a movie of what's happening. And yeah, QM neutron, the quantum neutron, is contingent on the planetary atom. Very important point, because what is helium? Well, helium supposedly has 2 protons, 2 neutrons, and 2 electrons. But what is that? It's the little electron moving around, okay, orbiting this nucleus made of 2 protons, 2 neutrons. So the math is there. They're saying you have the helium atom looks like 4 hydrogen atoms. In fact, with that, they can explain how the sun works, you know, at the center of the sun. You have 4 hydrogen atoms fused into 1 helium atom. And what's released is so-called word called energy. Great. But then the question is, you have 2 protons, 2 neutrons, and the 2 electrons are orbiting. So the neutron notion, the notion of the neutron, is contingent based on the planetary model of the atom. If the planetary model is no good, or you don't accept it because you can't explain how the electron bead does not fly out of the atom, then all bets are off. Then we have no neutron. Okay. And finally, if neutron decays to proton and electron, the rope model can simulate this phenomenon with flying colors. Okay, so we do have a physical proposal for how the neutron works, what it is, what it looks like. Quantum has none of those. It cannot explain except in mathematical terms. It cannot explain in physical terms. Okay, let's go on with the questions, the comments that people made since last time. Well, it says, what happened here? I don't know why I can't see it. Why can't I see this? Give me a second here. I don't know what happened. I put this thing up there and I can't see it. Why can't I see it? Okay, I guess I'll have to go with the second one or what? Yeah, there it is. I don't know why I can't see the first one. Something happened to that. So one of the questions you'll have to take a rain check next time. It had to do with calculating mass. Okay, I don't know why I can't see it. Give me a second here. Let me get it out of the way. Okay, fellow says peer review part of the scientific method. Is it? Subjects scholarly work and research to the scrutiny of other experts in the same subjects scholarly work and research to the scrutiny of other experts in the same field to check its validity and evaluate its suitability for publication. Okay, scientific method attempts to minimize the influence of bias or prejudice in the experimenter. Okay, that's assuming experiment have anything to do with science, right? We can do all kinds of experiments. It doesn't mean we understood anything. You know, a famous experiment, we let go of the pencil. Okay, we did the experiment. We do it again to check gravity, right? Again, twice it fell down. We did a repeatable scientific experiment. Now, because I did an experiment, does that mean I understand what caused gravity? So yeah, you can do a lot of experiments. Experiments is not a part of science. Explaining the experiment, that's the part of science. That's the part where science vibrates. But to do an experiment, say, I did an experiment. Okay, what did you do? I jumped into the pool and I did it 10 times. What did you learn? Well, I didn't learn much, but I did it. I did the experiment, so I'm a scientist. No, doing experiments is not science. It's explaining experiments that is science, explaining the mechanisms. But here we have, give me a second here. This is the answer to the peer review, okay? Who gave them the authority? Who gave these monks, you know, the authority to serve as judges over you? Did you give them the authority? How do you know they know? From whom do they learn? I mean, here we have these so-called monks, and they come up and they say there's something called a zero-dimensional singularity, which swings stars around itself. And then we have four-dimensional space-time, which we cannot imagine, which is the cause, the reason, you know, that the Earth doesn't fly out of the solar system, warp space-time. And so apparently they don't know much, and you're going to give them the authority to rule over you, to peer review your paper? I don't think so. Will you submit your paper to review by these individuals who believe in these kinds of things? Will you submit your paper to review by an individual who believes that a particle can be in two places at once? It sounds peer review is merely a way to preserve the status quo. So no, we don't use peer review in science. What we do is We criticize, yeah, you can say that's peer review, but if the person, presents his case, presents the objects and a theory, uh, it should be published as long as he follows the scientific method. And that should be straightforward. Um, you can check to see if he followed the scientific method. That's about as far as peer review should go. But the merits of the theory, is a question of belief. And so, once the guy follows the scientific method, there's nothing wrong with the theory. Okay, the theory, whether you believe it or not, which is what peer review is all about, what you're going to allow to be published out there, that's called censorship. That's not called peer review. Okay, not called science for sure. Okay, another fellow says or asks says, if the rope forks at the atom, one thread for the electron, one for the protons, then shouldn't they both weigh the same? In other words, the proton should weigh the same as the electron, right? Because they're all made of same threads, right? Or have the same mass. Well, the issue here is that we're comparing apples and oranges. We're comparing quantum mechanics against the rope model. And under the quantum mechanics, when they talk about the electron weighing 1,800 times less than the proton, what they're talking about a little dot that allegedly, orbits the nucleus. And so they say, well, this one weighs less than that one. Under the rope model, what they're talking about is a little point on the edge of the membrane that encapsulates the proton. Okay, so that's what we're talking about. So we're not talking about the whole membrane. Okay, and so you got to keep that in mind. But here's part of the answer to that, what this fellow raises, and that's that how they calculate the mass of the electron. And again, it's not like they really go out there and weigh the electron, put it on a scale or anything like that. This is one of the methods that they use. This came out of the Max Planck Institute. They blast off carbon-6 electrons, okay? And they induce the C12, a single electron, to race around a circuit. Okay, so they have this C12 going around, carbon, right? They calculate the length of the circuit, okay? They count how many times the C12 goes around, okay? They estimate the C12's speed, right? And the electron spin precesses in this magnetic field. And then they do a calculation. The revolution frequency of C12 and electron spin precession are in an exact ratio of one to another. That's the way they calculate it, okay? Again, it's a calculation based on the notion that they're talking about the planetary model of the atom, okay? And so people don't always understand that that's the case, okay? What we're talking about here is the planetary model, which later on they deny at the end of their lecture. They say, oh, by the way, that atom that we talked about for the last 2 hours, that's not our atom. So they talk about the electron bead, right? They're going to pull 6 of them out of the carbon atom. They're going to run the carbon atom around. Then they're going to look at spin, which is not spin, by the way, another topic. And they say there's a ratio there, and based on that, they do a calculation. They say this is the electron spin, electron mass. But what do they base it on? They base it on the planetary model of the atom. They're assuming the electron is a bead to begin with that's going around. Okay, so they don't know what they're doing, but the calculation is what they are concerned about. And they say, well, the electron, in order to make this work, the electron would have to weigh so much. Okay, so that's how they calculate this. But they've never seen an electron. They don't even know what an electron looks like. Okay, so unless you understand that to begin with, that they're working off of the planetary model of the atom, which has no rationality whatsoever, because you cannot explain why the electron bead does not fly away or fall into the nucleus. What's keeping it bound to the nucleus? Unless you can answer that, you don't have an atom to begin with, and the assumption under which they do all these experiments is already baseless. It's irrational. You have to understand that part first. Okay, you got to go deeper before you just gawk at the experiments that these people do and say, "Oh man, these guys are so smart." Now they're not so smart because before you do an experiment, you got to do a design of experiment. These people have not done any design of experiment because if they put it on the board, whatever they put on the board is nonsense. They're going to put a planetary model there. Okay, that's where the whole thing fails. Okay, we have a flat earther. He came over and he says, just like the globe Earth, all mathematical physics, nothing but the globe can be practically demonstrated. Nothing about the globe can be demonstrated. All it has is interpretations of non-tangible, visible phenomena, luminary's interpretation based on assumptions that are not tangible. Try it, Bill. See if you can find find one practical, real-world, physical demonstration that supports any globe Earth claim. Why are you not looking at this objectively? I have looked at it, and I keep showing it, but these people never show up. They never show up to question or criticize what I put up there. So they just run away. They do a hit and run. They just leave and they never come back. And all they do is just say, "Oh, see, you cannot explain the water around the Earth. You cannot explain the air around the Earth in a globe, in the globular Earth." And I have, and I've done it several times. And I keep doing it, but these people never come back. So only for those people who want to know what the answer is, here it is. Okay, we have here the Earth. The globular Earth, the spherical Earth, more or less spherical. And what you have is all these atoms. They're known as water and they're known as air. And all these atoms are tied to the center of the Earth by ropes, by electromagnetic ropes. All atoms in the universe are physically interconnected. So they all pull towards the center of the Earth. Whether they're water or they're air, it doesn't matter. The reason they don't fly away is because something is connecting that atom to the atoms that make up the Earth. And of course, the only possibility is a sphere. And that's why all the objects in the universe, more or less, are spheres, because they all rely on gravity. What is gravity? Gravity means that all atoms are physically interconnected. Physically interconnected. That's the only way you can explain not only gravity, but why everything is roundish, why everything is spherical out there in the universe. Okay, so yeah, I get sick and tired of explaining this over and over again. These people never come back, because they came back, these guys, and they would say, "Okay, I see what your point is." First, they have to understand it, and they never come back. So, of course, they never understood it. All they do is just gripe. And of course, one of the things that a flat earther will always do and say that we never went out into space. Because if we show them that, we got pictures from outer space of the Earth, well, that destroys their whole argument. So they have to deny that we ever went into outer space. They say, no, that's a hoax. That's, just government feeding you nonsense. So how do the satellites work? I mean, how does your phone work? They say, a little string, stretching from England all the way to, Newfoundland, underwater. They think we're still in the wire age. Poor people. Okay, anyways, continuing here. Bill, you keep on attacking math, yeah, but we keep on seeing phi, the golden ratio in nature's design. So surely math has a place in explaining our universe. Well, math only describes. All phi is, whatever that is, it's just a description. You haven't explained anything. So you need to understand the difference between a description, which is what math does, and science, which is explanations. Explanations are not descriptions. Descriptions are not explanations. You can explain a mechanism, and math doesn't do that. Math can't do that. It has no power whatsoever to explain. Math can only describe. An equation is only a description. Okay? That's why the mathematicians converted math into science. They say math and science are synonyms because that's all we can do. And it's objective because math is objective. Yeah, because math is a language, is a tautology. What's on one side of the equal sign is the same as what's on the other side. So math is a tautology, that's all of relations. And all those are just descriptions. Any equation, any formula, any number out there is only a description. All you're doing is describing something. You haven't explained anything with that. You cannot tell me what exists out there in the invisible, intangible world of Mother Nature's. You cannot tell me what causes gravity because you can't see the mediator of gravity by doing math, by doing equations. And that's the problem. So what have the mathematicians done? They said, well, math is the real science and everything else is opinion. And no, it's the other way around. Math is just a language of descriptions. Science is explaining. That's what physics does. Physics, rational explanations of mechanisms. Okay, so another fellow along the same line says, oh, let's not burn at the stake the straw man we create out of mathematicians and their technologies. I may not be a scientist, but I know science when I see it. Well, you must have pretty good eyesight because you can't see science, okay? But anyways, no, mathematicians and technologists, they're not scientists. Anyone who does experiments is known as a technician, a gopher, lab boy. What is a mathematician? A guy who knows a language, just like there are people who know Chinese, Greek, etc. Well, this guy knows a language known as mathematics. That's all it is. It's a language of relations, language of adverbs. Only adverbs. That's all that mathematics has. What is a scientist? Nothing to do with what's on the left side there. A scientist is someone who explains something. He's got to explain a mechanism. Primarily, all the invisible, intangible mechanisms out there. Gravity, magnetism, light, electricity, and so on. So that's what a scientist is, a physicist. Okay. Okay, so you got to explain something if you want to do science. Otherwise, you're not a scientist. And if you did equations, well, great for you. All you did was a language. You could have put it in Chinese also and say, okay, this equals that. You could have put it in words. And all you did was describe. You haven't explained anything. Okay, a fellow says we can prove fields physically exist just by observation. Okay. So he says, well, you look up the word field, let's see, it says a value for each point in space and time. So how can you observe values in space and time? What are you observing? What are you seeing? You got special eyesight, maybe. And then, nevertheless, proof is in the pudding. One fellow there says, proof is what whiskey has, right? Persuading, convincing, urging someone to convert to your beliefs. That's all that proof is. So we don't prove in science. That's in religion. You're doing religion, not science. And so, yeah, we don't prove fields, first because we don't prove, and second because you can't observe fields like, with your two eyes. So no, don't strain your eyes. You won't be able to see a field because there's a bunch of numbers. Okay, value at each point in space and time. That's all a field is. Okay, another fellow says, how do ropes explain gravitational attraction unless the ropes are elastic like rubber bands? If the ropes are elastic, how far can they stretch before they break? Well, no, they don't stretch. Fellow obviously has not watched enough of this channel to understand, but there it is in a nutshell. Nothing stretches, because if the ropes or the threads really stretch, you would be creating matter from vacuum. Where would the slack come from? So the thread is made of a single piece. Okay, it's all the matter in the universe, just this thread winding around from atom to rope, rope to atom, atom to rope, rope to atom. And it's a single piece, it doesn't stretch. And the way we produce gravity is every atom in the universe is connected to all other atoms through the rope. Okay, there's a twined pair of threads between any two atoms. And what you see there is that the farther two atoms are apart from each other, really two objects made of many atoms, right? They are far apart from each other. Then all the ropes come closer to each other and they act almost as one, as a single coaxial. The closer the two objects come to each other, the ropes fan out. Okay, so acceleration of gravity is simply the fanning out of the ropes. That's in a nutshell. You can look up other videos that I've made out there, and even the book, There's a book there, free book, downloadable book, The Rope Hypothesis. You can find it in my website. That's in the description. Okay, Fowle says, last issue here, he says, could you explain how the different atomic substances, the elements, the elements of the periodic table, are accounted for in the rope hypothesis model? Okay, and so all I can answer to this gentleman is that is a subject of next time around. On Wednesday, I'll be talking about that, and so I'll answer your question then.